All right, last few problems with this section of logarithms. So we're given that log, the common log, so log base 10 of 6.92 is roughly equal to 0.8401. And that, just looking at it at first, I'm sure that kind of makes you go, well what? And so let's look at what that is actually saying. It's saying that the base of 10 to the 0.8401 power is roughly, not equal, I shouldn't write equal, is roughly equal to 6.92. If we change that from logarithmic form to exponential form, here's what that is saying. And that decimal exponent right here, this 0.8401, think of it for a second as maybe 10 to the 8,401st power over 10,000. Because as a fraction, those now say the same thing. And so this would be 10 to that huge power, but then to the 10,000th root. And so it'd give us a number that is less than 10. But it's, because if this was just 1, it was up a little bit higher, it wasn't 0.8401, but was just 1, then we'd end up with exactly equal to 10, because 10 to the first power would be 1. And this is a bit smaller than 1, and so our number is a bit smaller than 10, and that's really all that's going on as far as that's concerned. Now, as we go through here, remember that the roughly equal to 0.8401 is talking about the exponent. So how many tens are multiplied together? And as we go through here, if we can keep that in mind, these next couple problems will be a lot easier. So again, log base 10 of 6.92 is roughly equal to 0.8401, meaning an exponential form that base 10 to the 0.8401 power is roughly equal to 6.92. So let's go ahead and use that. We've got log base 10 of 692, and we want to figure out what's that roughly equal to. And so this is going to be log base 10 of, but now let's change the way this is written. This is going to be 6.92, notice the relation between these two numbers right here, times 10 squared. Okay, well, if we have another two tens being multiplied in with our 0.8401, another two tens would just be two whole numbers. It would be 10 to some number, let's say 10 to the x power, times 10 squared. Well, you would add these exponents. So we're going to add them in together. We would get 10 to the x plus 2. Now we know what our x is, though. It's 0.8401. All right, so we get, this is going to be the same thing as log, sorry, not log, but of 2. So this is roughly equal to 2.8401, because there's two more tens being multiplied in. So maybe another way to look at it would be it's log base 10 of 10 to the 0.8401 times 10 squared. And so we have a log of base 10 of these numbers. And so it's really just the exponents we're looking at. We're going to add those together and get 2.8401. And so same thing over here. Hopefully you notice that, hey, this went from 6.92 to 69.2. And how much bigger is that? That's 10 times bigger. So how many more 10s are we going to have in right here? We're going to have one more 10. And so just think of it that way. Hopefully you can already get to the answer of 1.89, or sorry, 8401. That 8401. That's going to be our answer. But let's go ahead and look at this a little more. So we've got log base 10 of 6.92, our original given information up here, times 10 to the first, and that is log base 10 of 10 to the 0.8401 power times 10 to the first power. And so we end up with log base 10 of 10 to the 1.8401 power. And just like our rules from, I think it was back on the last page, we have log base something, so base 10, and then that being to that base right there. Well, then our answer is just that exponent. So again, the answer is 1.8401. All right, let's look at these last two, and then we're done with this section. So natural log of 5 is roughly equal to 1.6094, and we're supposed to find the natural log of 0.2 and the natural log of 25. Now this first one's probably a little bit tricky. We saw that we wanted to change it into the same base, but 0.2, well, that's not even 5. How are we going to do that? And so remember that this actually is something to do with 5. That's 1/5. That 0.2 is 1/5. Being able to see that will help you out quite a bit. And so our first step would be changing this, and you could want to, if you wanted, even change it to the natural log of 1/5. That might help you see kind of where we're heading. All right, so natural log of 0.2 is going to be the natural log of 5 to the -1 power. And that's the same thing as the natural log of 5 to the -1 power. And we know what 5 is based on this information right here. What is 5? Well, let's convert this into exponential form. That is base e to the 1.6094 power is roughly equal to 5. And so we can substitute this in for 5 now. So we're going to have the natural log of e to the 1.6094 power to the -1. And we'll end up with the natural log, next step will be the natural log of, now we're going to, if we have the exponent to an exponent, then we multiply those together. So natural log of e to the -1.6094 power. And then remember, natural log, its base is e. And so we're, again, with our rules, the base to that, multiplied by that, or of that base, gives us just the exponent. So our final answer is just our exponent. We're taking the log of that. And so our answer is -1.6094. All right, and last one, and then we are done. So good job kind of fighting through this section. Natural log of 25, and 25 hopefully is a little bit easier to see why that's going to be a base of 5. So natural log of, or sorry, not a base of 5, but how we can change 25 into 5. So that is going to be 5 squared. Now 5, we know what 5 is. It's e to the 1.6094 power. So the natural log of, I'm going to substitute that in, e to the 1.6094 power squared. And we're going to, if the exponent of an exponent, we can multiply those together. So the natural log of e to the, let's see, what is that multiplied by 2? So 3.2188 power. I think that's right. And if it's base e and then of e, we're really just finding the exponent, and our exponent is right there. It's 3.218 8. All right. Hope that helped.